Alright, kiddos, hope you're having a nice snow day. Might be 2 snow days, but this video I'd like to go over that one problem from the homework from the last video, and at the same time equip you with some tools that will help you work through the rest of the assignment for tomorrow or whenever we next meet in school. So that's it. Let's go over the one question. So again, we're talking about sine and cosine, right? But we write them really as sine of x and cosine of x. Or sometimes you'll see sine of theta, right? Theta being that angle. Okay. So the question I asked you to consider for today was, what is the cosine, I believe the cosine, of 135 degrees, right? And we're establishing what that means and how we get that value, okay? So here's what I have for you to consider, okay? First, we're going to start from the unit circle, and using the definition of sine and cosine, we begin resting, as we always do, peacefully, initially, along the x-axis. And I'm going to rotate that 135 degrees, right? So 135 degrees is going to work through the first quadrant and into the second quadrant, right? So to the first quadrant, that's 90, and then I need 45 more to get to 135, right? So there's my 135 degree rotation, right? And of course, if I'm evaluating the cosine of 135, that rotation needs to be 135. Right? Now, recall that by definition, the terminal point, the point at which I land, is defined to be the cosine of the angle that got me there, and the y value is the sine of the angle that got me there, right? Now, because it's not one of the nice four, what I call lattice points, for which we know values, 1, 0, this would be 0, 1, negative 1, 0, 0, negative 1. You have to figure out what the heck the coordinates are for that terminal point, right? So we're going to use special right triangles. Recall the hypotenuse is and always will be 1. So the question is, what kind of triangle will help me evaluate the x and y value of that terminal point? So I'm going to drop an altitude, and I would always drop or raise altitude. Some people do left or right, but it's just consistent with what you'll learn in the future to drop that altitude. Okay? And the question is, what kind of triangle, reference triangle, have I created here? And so the reference triangle is this triangle in here, right? The triangle that we use to evaluate the x and y value of the terminal point. Now remember, the x value of the terminal point is the same as the base of that reference triangle. The y value is the same as the height of that reference triangle. That's why we need that reference triangle. So what I'm going to do now is try to figure out what the heck this reference angle is, right? So a couple ways to do it, right? If to go the 135 degrees, there are essentially 45 more to get me to 180, right? If I ended up here on the x-axis here, that would be 180 degrees, right? So this terminal angle is 45, excuse me, reference angle is 45 degrees, right? Another way to think about it is, well, here's 90, plus this would be another 45, and then that would make another 45 here to make that 90 degrees for this quadrant. Right? So any way you slice it, that reference angle, which I need for my reference triangle, is 45. Oh, so I got a 45, 45, 90 triangle. Bam. Okay. Now, most of the problems we've done so far have pertained to 30, 60, 90 triangles. So here's what I would have you consider. Okay, and I would write this down if I were you. Okay, put a box around it. So for 30, 60, 90s, and we've already established it, the hypotenuse is 1. Oh, the side across from 30 is half that, so half of 1 is 1/2. The side across from 60 is root 3 times the x side, the 1/2, which we just call root 3 over 2. All right? So put that down in a box in your notes and keep it there. Okay, the other triangle, which we have not yet considered, would be a 45, 45, 90 triangle, okay, which we need for this problem. Now recall the hypotenuse is 1 because we're dealing with a unit circle. The radius is 1. The radius will be the hypotenuse of your reference triangle always. And so what I asked you to consider is, well, how on earth do we get these other two sides? So I'm going to bonk down to the next page. Right? So I'm trying to figure out if that's 1, what are my other two sides? So 1, remember, is my x root 2 side, and the other two sides are called x, using my 45, 45, 90 ratios. So if 1 equals x root 2, if I multiply both sides by root 2, I get 2x equals root 2. And then if I divide both sides by 2, I get my x value. Okay? Right? So therefore, my other two sides are going to be root 2 over 2. Okay, so I would urge you on your note paper, put a big box, a big circle around these two triangles, because we're going to come back to those over and over and over again. Like, for example, in the problem you considered for today, or whenever. So what essentially I need to do is transfer this information. So 45, 45, 90, that's root 2 over 2. That's root 2 over 2 if the hypotenuse is 1. And the only thing I now have to consider is, well, what quadrant am I in, and what things are positive and negative in that quadrant, right? So now, because I'm in the second quadrant, I move to the left root 2 over 2, which means this value isn't really positive root 2. That's right, negative root 2 over 2. Okay? I'm moving up from the origin, therefore my y value is positive root 2 over 2. Okay? Therefore my terminal point, negative root 2 over 2. The base, positive root 2 over 2, the height. And since I want the cosine, I want the x value. So there is the solution to the problem that I asked you to consider at the end of the video. Okay? So, what I want you to do, I'll post the assignment on Canvas, but what I want you to do is make sure that you're able to use these triangles over here. So copy them down, right, put them in your notes, put a rectangle or circle around them. We're going to go back to that over and over again. Okay. Here's one idea I also want to introduce to you, and it's called radians. Now there are two ways to measure angles, right? Radians and degrees. Radians you probably never heard of. Degrees is comfortable for you, I hope, right? The way in which we relate them is pi radians, about 3.14, is the same thing as 180 degrees, right? So therefore there are some benchmarks, right? So if pi is 180, then pi over 2 radians would be the same thing as, well, just divide by 2, divide by 2. Yes, that would be 90 degrees. Right? So that's a good benchmark. So if I know pi is 180, then pi over 2 is 90 degrees. Right? So if I know pi over 2 is 90 degrees, then hey, 3 pi over 2 would be 3 times 90, or 270 degrees. Right? 5 pi over 2 would be 5 times 90, or 450 degrees. Okay. Some other benchmarks are pi over 3. So if I divide pi by 3, I divide that by 3, of course that ends up being 60 degrees. Right, so if pi over 3 is 60 degrees, then I can use that benchmark to think about, well, 2 pi over 3 is going to be 120 degrees. Okay. Some other benchmarks, and I'll work through this with you, would be, running out of room, pi over 4. I'll write it over here on the side. Here's some other benchmarks, all of which come from the initial conversion, right? By definition, pi radians is the same thing as 180 degrees. And so another benchmark I could use, pi over 4, divide pi over 4, divide 180 by 4, and 180 by 4 is 45 degrees. Right? So if I know pi over 4 radians is 45 degrees, then 3 pi over 4 would be 3 times 45, which is 135 degrees. Okay, so we can use these benchmarks. And again, just like these right triangles, special right triangles, hypotenuse 1, write them down, put a box around them. Also, write these down and put a box around them. We'll use these over and over again. The last benchmark would be pi over 6. So I want to divide pi by 6, so I divide 180 by 6. 180 by 6 is 30. All right, so if pi over 6 is 30, then I could use that benchmark to get, say, 5 pi over 6, right, which would be 5 times 30, or 150 degrees. Okay? So put these benchmarks in your notes. Keep them there. You can put a box around them. It will help us with our conversions. But all of these stem from, kind of initially, pi radians is the same thing as 180 degrees. Right? So that's where we start by definition. That's what pi radians is. And you're probably asking, well, what would 1 radian be? Well, 1 radian would be 180 over pi, which is, what, 57-ish, I believe, degrees. Okay? So that's something new that I want you to consider, and that's going to help you work through the packet. Okay? Now for your homework, what I would like you to do for Friday, maybe, if we have school, or Monday, is I want you to work through the problems on 2, 3, and 5 of your packet. The packet is on Canvas. Okay? So for your homework, I want you to work on pages 2, 3, and 5 of your packet, converting radians to degrees, degrees to radians, and also evaluating sines and cosines. Right? So one more thing I want you to consider. What if I asked you to evaluate cosine of 2 pi over 3, right? So most students would say, okay, that's radians. I don't quite know what that means. So well, I'm just going to change that to its equivalent degrees, right? So, 2 pi over 3 radians. Well, I remember my benchmark. Pi over 3 is 60. So 2 pi over 3 is going to be 2 times 60, or 120. So I'm just going to replace that with 120 degrees and proceed to evaluate the cosine as I normally would. Okay, unit circle, 120 degrees, end up right here. That's 120. So what's left of 180 is 60. There's my reference angle. I'm going to drop that like it's hot. Hypotenuse is still 1. This would be 1/2. It's across from 30. This would be root 3 over 2. But actually, that's really negative 1/2 because I'm in the second quadrant. Right? Therefore, the cosine of 120 would be negative 1/2, which is the same as cosine of 2 pi over 3 because these guys are the same. Okay, just different ways of expressing the same angle. 2 pi over 3 radians, 120 degrees. Okay, so good luck. Perhaps I'll see you tomorrow, maybe on Monday. Bye-bye.